Welcome, ladies and gentlemen. So what I like to do is show you how to find the direction of a vector. So a lot of times, when we have a vector, for instance, like this vector, 1, 1, let's do big ones here. Boom, 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 boom. We talked about the magnitude, which is basically the length of the vector from the initial point to the terminal point. But then a lot of times we also want to find, the direction, right? And where is this vector, going? We know that the initial points, we know the end points, but what exactly is that direction? We worked along in those another video when we were just given the angle as well as the magnitude to write the vector. So therefore, we have a direction that is attached with the vector. Now, if you were to think about this vector, again, the best way to think about direction is to think about your angle theta in respect to the x-axis and your vector. So again, if I create a terminal side, we don't know what the magnitude is of the vector. We could obviously figure out the magnitude and then use our trigonometric functions, cosine or sine. But since we don't know the magnitude and finding the magnitude would be more work, we're just going to want to use these two, the opposite and the adjacent. So therefore, that's where the tangent comes from. Because if you see here, that's V2, I'm sorry, that's V1. V1, comma, V2. So if that's V1 and that's V2, that's the opposite, that's the adjacent. So to find the tangent of an angle, all we're simply going to do is take the tangent of theta is equal to V2 over V1, then use the tangent inverse of both sides to find theta. So I'll work through the first one kind of step by step, even though the first two examples are fairly simple for us to be able to figure out. But I'm just going to write it out. So this one is V1, that's V2. So I say tangent of theta is equal to 1 over 1. Now again, to figure out what theta is, that's what we're asking, we need to use the inverse function. So I'm basically going to do tan inverse of both sides. And therefore, I'm left with theta equals tangent inverse of 1 over 1, which is just 1. Now, some students automatically go ahead and rush to their calculator and saying, OK, let me go and plug it in and see what I get. Now, we are going to use our calculator. And since we're using angles that, or we're going to be wanting to find our angle in degrees. So make sure that your calculator's in degree mode. If for some reason you're finding an angle in radians, which we don't really use much at all in degrees, or in vectors, so let's just focus on degrees. Anyways, again, what is this asking? This is saying the angle, theta, is equal to the tangent inverse of 1. So what exactly is this angle when tangent is equal to 1? So going back on the unit circle, looking at the first quadrant, we know that when the angle is at 45 degrees, the point is square root of 2 over 2, comma square root of 2 over 2. If you take the y over the x, that's equal to 1. So therefore, theta is equal to 45 degrees. Done. In this example here, I'm just going to do tangent of theta is equal to negative 1/2 over negative square root of 3 over 2. Again, you can simplify this by multiplying by the reciprocals. You don't really need to. You could, but what happens is now we're left with 1 over the square root of 3. Rationalize the denominator, equals square root of 3 over 3. Now, we know this coordinate point is going to be in the fourth quadrant, right? I'm sorry, not coordinate point. We know this vector is in the fourth quadrant because that's negative and that's negative. Now, we simply just need to figure out is which coordinate point is when V2 is y and V1 is x. Well, that gives us this angle here, square root of 3 over 2, comma 1/2. So we know that is going to be 30 degrees, right? That's in the first quadrant. But we need to figure it out where it has the reference angle is going to be 30 degrees. So we need to figure out the angle from here to there, right? So theta, I'm running out of space. Theta equals tangent inverse of square root of 3 over 3. Using the unit circle, I figured out that square root of 3 over 3 is the same ratio as 1/2 square root of 3 over 2, comma 1/2. However, this angle or vector is not in the first quadrant, it's in the third quadrant. So I use the same reference angle and I say, all right, I need to figure out the angle from here all the way to there. So halfway around the circle is going to be 180 degrees, plus another 30 is 210 degrees. There you go. So this is, again, some practice with using the unit circle. In the next couple points here, I have the vector negative 3, 2. Now, I know this is not going to be on the unit circle. So what I'm going to do is I'm just going to simply cut to the chase. I'm going to write it out. And then I'm going to plug it into my calculator. And that's basically what we're just going to do here. So I'm going to use the second tangent, and I'm going to do negative 2 divided by 3. And I get 33.69, or negative 33.69 degrees. And again, let's go ahead and verify that we have a issue. 2 divided by 3 is 3. Negative 3, 2, that's not giving us correct. Ah, ha, ha, ha. I knew I was going to pick a problem like this. Negative 3, positive 2. Perfect. OK. So we need to kind of make sense of this. And again, I forgot I put this in there. So we need to make sense of this problem. All right. If you look at this, you say, well, negative 33.69, that's not in the second quadrant, right? If you were to sketch this vector, negative 3, 1, 2, 3, positive 2. Right? That's not negative 33.69 degrees. We have an issue here. So what are we going to, how do we kind of make sense of this? Well, we have to remember that when we're talking about the inverse tangent, right? Inverse tangent has a range of only between negative 90 and positive 90. That means it's only going to give us that value between the negative degrees and the positive degrees. So basically what it's doing is it's saying that's negative 33.69 degrees. So what we need to do is we need to basically figure out what this angle is from there. So what I'm going to do is I'm going to take theta equals, and basically this is the same as over here. So I'm just going to take 180 degrees minus 33.69 degrees. And that is going to equal, so 180 minus, minus second answer. That's going to give me 213.69. 213.69. And that's not, oh, wait. Oh, oops. 180 minus 33.69. Sorry, I typed that in wrong. That gives me 146. OK, now does that make sense? Does that look like that is 146.3 degrees? Yes, that works, OK? So be very careful when using the inverse tangent to make sure that if you're finding a vector that's not within the range of your inverse function, that you're going to have to do a little math to find that angle. Just a little FYI. Very common mistake. The next one I have 3i minus 5j. So again, sometimes it's just helpful to sketch the vectors. 1, 2, 3, 4, 5. OK, so I know this is going to be in the fourth quadrant, which falls within my range of tangent. So that's perfectly OK. I'm good on that regard. So now I'm just going to do the tangent of theta is equal to negative 5 over 3. So theta equals tangent inverse of negative 5 over 3. So I do inverse tangent of negative 5 divided by 3. And I get negative 59.036 degrees. Okay. And the last one here is I want to find the angle. So again, this one, a lot of times when I'm dealing with these unit vectors, basically, let's just look at this. Negative 3i, remember, here's my unit vector I, here's my unit vector j. Right? So if I'm going negative 3i, 1, 2, 3, that's going that way. Well, writing in angles, what is going to be that exact angle? Remember, we write angles in standard form is going to be from 0 to here. So therefore, my angle of my vector, theta, is just 180 degrees. So there you go, ladies and gentlemen. That is how you find the angle of a vector. Thanks.